Good morning, mathematicians. Today we're going to learn how to solve this type of integral. So first, we have to analyze it and think, what kind of function is it? We see it's a trigonometric substitution type of integral. And since we see that there's a plus here, we can see it's a case 2. Okay, so first of all, we have a lot of s's here, and we have to find out what is s. So we use an original formula that says that s equals a tangent theta. Then we have to know what is a. Here we see a is 8, because 8 times 8 equals 64, that is inside our square root. Okay, then we merge these two together to get that s equals 8 tangent theta. Our next step is to derivate this so we can get our ds. That will help us integrate later on in our function. So ds equals 8 secant squared theta times d theta. If you got this answer, you're going to be happy. If you didn't, you're going to be sad. Now with my partner Jacob.
In the second part, we simply have to substitute in our original function the value that we obtained before. So we know that our ds is 8 secant squared theta of d theta, and we know that our s squared is 64 tangent squared, and here we have a square root and with s squared plus 64, and if we solve it, we end up with 8 secant of theta. So here we can see that we can cancel out secant and secant, and we end up with secant integral of secant theta d theta and 64 tangent squared theta. Since here we have a 64, we have to take it out and cancel out. So we end up with secant theta d theta tangent square of theta. Here it is. And here we have to transform it using sine and cosine. So here we know that secant is 1 over cosine, and tangent squared in this case is sine squared over cosine squared. We multiply it and we end up with cosine of theta over sine squared of theta.
Okay, now that we have this, we're going to substitute it into our function. And we have 1 over 64 integral of cosine over sine squared of theta. We're just missing a d theta right here. Okay, so first we have to see which one is the derivative of the other one. And we see that sine, if we derivative it, we get cosine. That's why we choose this as our u. And after derivating, we get cosine theta d theta. Then we have 1 over 64 integrate of du over u squared, as we see here by substituting the two elements we got over here. The next thing we have to do is pass this up so it's simpler. So we have 1 over 64 u to the negative 2 times du. Now it's time to integrate. So we have 1 over 64 times u negative 2 plus 1, and we do the same on the bottom, negative 2 plus 1. After simplifying this, we got negative 1 over 64 u to the negative 1 plus c. This is very important. Here you have to add your c. Then we substitute our u to this function, and we get 1 over 64 sine theta plus c. With my partner Jacob.
This should be our final answer, but we don't know what our sine is. So we know that our s is equal, as we seen in the first step, that our s is a tangent of theta, and we solve for tangent. That is s over a. We know that our a is 8, so our tangent, we know that is s over 8. Here we have to use the Pythagoras theorem, and if we draw our triangle, we know that this is our theta, this is our hypotenuse, and those are our opposite and adjacent values that are s and 8. We know for the Pythagoras theorem that c squared is equal to a squared plus b squared. We substitute our value, and we know that our hypotenuse is equal to square root of s squared plus 64 plus 8 squared, that is 64. Then since we have to solve for our sine, we know that our sine is equal to the opposite over hypotenuse. So our sign is equal to s over square root of x squared plus 64. And we have to integrate it, adding our c, important. And we just arrange it in order to cancel out this numerator, and we find out that our final answer is minus square root of x squared plus 64 over 64s plus c. This type of problem are useful in our real life as an application if we have to solve something real complex using the Pythagorean theorem. And when we don't have some values, we can use the trigonometric substitution method in order to solve it.